What's up, everybody? Welcome to the inaugural stream of Flux Harmonic. I apologize for the confusion. I actually just had an issue where I apparently didn't even start the stream because I have a new YouTube account and I haven't streamed with it before. I don't have all the same settings that I'm used to when streaming with the System Crafters channel. And somehow I managed to not even start the stream, which is great. So we're off to a great start, I have to say. So if you're joining us this morning, please let me know in the chat if you're here. I saw some people waiting and chatting. I apologize to you who were waiting and were wondering why I wasn't starting things. I actually have been sitting here talking to myself for about 5 minutes, which is great. So anyway, to get back to what I was saying before, today is the first episode, I guess you could call it, or the first live stream for the channel Flux Harmonic. And as I described in the welcome video that I posted a few days ago, the idea here is to be more of a live coding project focused channel where you get to watch me go from basically from scratch, building a lot of different things that are personal projects and things that actually might be pretty interesting to see as part of this channel. So it's not going to be like System Crafters where we do like tutorial videos and stuff. This one's going to be primarily focused on live streaming, live coding, live creativity. And then you may see summary videos or maybe one-off little videos here and there explaining some things, but this is not meant to be an educational channel per se. It's more meant to be, I guess you could say, educational entertainment, in that you get to watch me learn how to do things and figure stuff out on the fly. Maybe you'll gain something from that. I think the biggest benefit, if you're a viewer of System Crafters, is that you'll get to see me applying a lot of the stuff that I've been talking about on the System Crafters channel, but in actual actual development scenarios, actual workflows, etc. So we're going to be building up a lot of this stuff from scratch while we go, and we'll figure out a lot of interesting things along the way, I think, with Emacs and Geeks. I want to say hello to, let's see, Mark. I think I saw Hyder. Yeah, Hyder's here. My Thili, sorry if I'm pronouncing that wrong. Appenzel, Gan, Alexander. Thank you all for being here. I really appreciate your support in being here today. Looks like my chat is also working on the screen, which is great. Yeah, so I'm trying to have this stream have a different visual feel than the System Crafters videos and streams, because I don't want it to look like just the same channel all over again. Right now, I've got some things set up, but I want to improve the setup as time goes on and make it even more distinct from System Crafters. So I'm hoping that a lot of the stuff that we are able to do in the projects on this channel will help us to make this channel stand out, but also to improve the System Crafters channel as well. I think it's going to be pretty fun. Okay. What else was I saying? Oh, yeah. So I'm also going to be using different background music as another way to sort of distinguish this from System Crafters. And I'm using a playlist on Spotify right now. I don't really know what music's on here. I'm just sort of playing some, what do you call it? Royalty-free music from Streambeats. So if the music is annoying or if it's too loud, let me know and I'll try to adjust it a little bit. But I wanted to have at least some baseline level of sound so that you can not hear my child probably screaming in the background. So it's just there for noise. And over time, the plan is to make new background tracks for this channel and for System Crafters while we're doing these live streams. So that should also be a fun thing we could do in the future. 416 Kishore S says, what's today's topic? Let's talk about that, actually. Hi, Olivier. All right, so the overall goal of this channel is to basically create an audio-visual playground that I use to create music, videos, graphics, and even games live on stream. So I've got pretty high ambitions here, but I'm pretty sure we'll be able to accomplish some of these things. I've been doing game development, I've been making music, I've been doing video editing, video creation for a long time, so I have a lot of experience in all of these domains. But what I want to do is build my own tools for creating this stuff. Basically make things very hacker-focused, so that all the things that I create can actually be expressed potentially in code, like potentially Scheme or Lisp code. And I can use tools like GNU Geeks to make it so that whenever I create something, I can actually reproduce it very easily at the point in time whenever I created it by using Geeks' ability to install all packages for a particular channel configuration, etc. So like I said, a lot of what we've been learning in System Crafters is going to apply here because we're going to be making creative tools that actually use this sort of functional package management style, and also using Lisp languages to power everything, which I think is going to be pretty cool. Ashra says, music is almost non-audible. You're probably right. Let me see real quick. if I can bump that. I mean, non-audible is better than too audible. All right, so I turn it up a little bit. We'll see if that ends up being annoying. Let me know. And while you're here, Ashraz, let me just give you the wrench. All right. So, I'll also say that the things that I'm going to build on this channel, I don't exactly intend for other people to use them anytime soon. Mainly, it's going to be stuff to scratch my own itch and to function as my own creative output. This is sort of like a live performance, if you want to call it that, where I'm building things and I'm using it to create whatever I have in mind for that particular stream. So eventually, these things might be useful to other people. I think that over time, I might be able to add a level of polish that would enable other people to actually clone the tools or use Geeks to build them and then try them out themselves. But for now, let's just assume that I'm going to be doing things very rough and just trying to get things working. And then later we can work on polishing things up after we make some progress. Gon says, you also mentioned hacking in C. Yes, we're definitely going to do that. I'll talk about that in a bit. Let's see. I can see that oh, okay. I've got desktop audio turned down super low here. Maybe that's a little bit more audible. We'll see. All right, so let's talk about, wow, I heard that one. Let's talk about what types of things I want to build here. I've got a few different categories of things that I'm interested in making. And this song is particularly annoying. Let me turn that away. Okay. So first of all, audio tools. So I'm really interested in writing synthesizers. I don't know if you know what a synthesizer is, but those of you who have played around with music creation, you've probably played with them before. A synthesizer is basically a piece of software that is able to synthesize audio waveforms based on a few different algorithms so that you can either create synthetic sounds, like, you know, things you might have heard in electronic music, or maybe even emulate real sounds. So I definitely want to try and build a few of these different things because I've always wanted to, but I never had a really good opportunity to do it. So if I'm going to be making music on this channel, I would really prefer it if I use my own tools for creating that music. So writing my own synthesizers is going to be a part of that. So we'll try to do something like an additive synth, a subtractive synth, FM, wavetable, sampler synths. We'll try all this stuff over time. I don't think that we're going to get to this part of it so soon because I need to have a more elaborate setup first and think about some things. But this is going to be one of the big areas, in my opinion, of this channel, like trying to write audio tools from scratch. Also, effects processors. If you want to make music, you're going to need some of these things like compressors, limiters, noise gates, reverbs, chorus, flanger, etc. All the standard types of plugins or effects processors you need for making things sound better, or just, you know, being able to mix things appropriately, that kind of thing. It may be difficult to write some of these things because I might need to delve into math a bit, but that's sort of what we're doing here, is like we're going to try to see if we can figure this stuff out live. And the sort of cherry on top of all this would be a custom music creation environment on Linux only. I'm not worried about Windows or Mac OS or whatever because I don't use those anyway. So I prefer just to focus on Linux. And that's going to be powered by either Jack or Pipewire. And I don't know if you... all right, let me turn the audio down just a little bit. I'll turn it down for all of us so it's not distracting to me too. Yeah. This weird stuff that's going on here. So in the Linux audio spectrum, if you want to do professional quality audio, you're using Jack for a long time. And it's basically a more advanced audio server system where you can have multiple inputs and outputs and wire things up however you want them to be. And it has served the community a long time, but there's a new thing that's come along called Pipewire. You probably heard me mention it on System Crafters if you watch that channel. It's sort of the next generation in terms of how audio is handled on Linux, and I find it to be pretty reliable and pretty promising. So I'm thinking about writing a lot of these tools against Pipewire instead of Jack, but we're going to figure that out over time to see whether it makes sense to do that. But it is kind of a promising area that I'm really interested in looking into. So the idea would be that either Jack or Pipewire would sort of be the substrate upon which all these other tools can be built and then wired together to build a music creation environment. And I'm going to try to make it so that this music creation environment actually uses code as the way to store the information about what's being played back. Now, you've probably seen live audio coding programs and stuff before where people were like, writing code that actually generates notes and stuff. It's not exactly what I have in mind. It might be something like that, but I'm thinking more in terms of a more traditional style music recording environment. I'll be using like an actual MIDI keyboard and maybe some other instruments as well. Recording audio snippets, recording MIDI snippets, but also storing all that stuff as S expressions potentially, or as some kind of language, so that it can be checked into source control and handled like code or data rather than just like binary information. So I think it's going to be fun to do that, but we'll see how far we can get with it over time. So visual tools. This is also going to be something very important for all of the work that I'm doing. So I want to create a custom video creation and editing environment. So on Linux, there are programs like Kdenlive, Shotcut, OpenShot, Pitivi, Blender, etc., that allow you to do like GUI-based video editing. But I would actually like to do something more code-based, so I don't have to deal with, clicking around in the user interface. It's such an annoying task to me to have to edit a video when I have to go click around on a bunch of little tiny UI elements to edit something. So I think that there may be a way to create a video editing environment and also synthesis environment where video editing is part of it, but then there's also effects that you can apply and all these things that can be done potentially with code. So that's going to be fun to do also. I don't know for sure, but that might actually be easier to do than the music stuff, but we'll see how that goes as well. I'm very excited about working on that. Visual effects processors of various types. I mean, to do video editing more than just normal cuts in existing clips, you're going to have to do some kind of effects processing on clips, like color correction or fades or any kind of effects for transitions, that kind of thing. GNU Ninja says FFmpeg. Yeah, I've already been looking into possibly using the FFmpeg libraries as a way to sort of stitch all this together, but some of it I want to write myself, and we'll see how that goes. Motion graphics tools for video animations and still graphics. I think this is the area we're going to start with because in my mind it's a little bit more tractable and easier to sort of get everything started, to start building a framework for everything by working on this area. So the idea would be that I would create a tool for creating thumbnails for videos, and also potentially animations that could be used in stream graphics or as video transitions in videos or streams, things like that. So this is something I think we can start working on immediately and actually make some progress on. And lastly, I kind of would like to work on like a whiteboard tool. Now, obviously, I could just open up any normal drawing application in Linux and just use a tablet or like a tablet with a stylus that connects to the computer and then draw stuff. But what I want is a way to sort of visually communicate ideas that I have and like sketch them out so that you can see them live while we're working on stuff, and then be able to easily save those images out and include them in the stream notes so that you can refer to them later. So eventually we'll try to do something like that, but it's not really something that is necessary immediately. All right, so on the programming side of things, at first, my idea is that a lot of this is going to be written by creating low-level custom C libraries. So basically, the core of all the tools will be written in C. And you may be asking, why not C++? Why not Rust? Why not X? I like C. I think it's pretty interesting. It's also a language where you kind of have to do a lot of stuff yourself, and it's easy to shoot yourself in the foot. So it might make it for kind of entertaining failures, I guess you could say, while doing all this. However, over time, it may be possible that I decide to look into using Zig as a potential secondary candidate for doing this, because I'm really interested in that language as a replacement for C. It's kind of a little bit higher level and has some really useful and interesting tools for compilation, especially across multiple platforms. So, I mean, the cross-platform stuff isn't as interesting to me for like the music tools, but if I were to do game development, then I kind of want to be able to do stuff cross-platform. Now, obviously, C is very cross-platform, but Zig has some pretty nice stuff too. So for now, everything, I'm going to try to do it in C. We're going to see how far we can get. This is going to be instructive for all of us because, like, C doesn't have list libraries. It doesn't have high-level data structures. So there's a lot of stuff we're going to have to figure out. But that's part of the fun, I think. Also, custom programming tools for quick live programming of native applications and audio plugins. So it's going to be really boring if you have to sit here and watch me recompile things a million times. especially if it takes a while. So part of what I want to do is make it so that I'll answer your question in a second, Ashraz. Part of what I want to do is make it so that it's very easy and quick to iterate on the native code parts of what we're working on. I'm not sure how we're going to do that yet, but that's part of the fun. We're going to figure it out. And also a custom scheme-inspired scripting language that powers the various tools and serves as an authoring and data format. So at first, we're not going to do this, but ultimately, I do want to have some kind of, you could call it a scripting language, or a control language, you could say, for all this stuff. And whether it gets compiled to native code or not is another story. I had been working on a language called Mesh whenever I was doing stuff for System Crafters channel. And I definitely want to get back to that, but I think that is way too deep for what we need to do for these other creative projects. So I may do just a simple interpreted language at some point that could be the language that powers everything. However, we're going to use Guile Scheme at first because it's there and it's really good. It integrates with C programs very easily. So I think it's going to be a good opportunity for us to play with Guile a lot while we're trying to learn it on the System Crafters channel this year as well, or let's say 2022. All right, so 1 second, I'll get to the chat. Let me just get through this last little bit here. Streaming tools. So I would like to come up with my own custom live streaming software. So OBS is what I use for recording videos and streaming, and it works very well. But it's another situation where you have to do a lot of clicking around in user interfaces, dragging things around on the screen, and it's very imprecise in my opinion. And it's also slightly difficult to replicate across multiple machines. They do have the configuration for all your scenes and everything else in a JSON-based format. However, they basically compress that JSON into like a single line with no line breaks, so it's very difficult to see diffs. This used to not be the case. I think in OBS 26, they actually wrote the JSON file out to the point where you could actually see diffs if you tried to check it into Git, but now you don't have that ability anymore. So I mean, that's only one reason why I would want to write my own streaming software. Other reasons are it's much easier for me to integrate all this other stuff that I'm writing directly into the live stream. So we can do things like interactive graphics that can be affected by the chat, or, dynamic transitions that actually are unique every time, all kinds of crazy stuff like that we could do. And, some of this sounds like, what's the point? Why would you want to do any of this? Well, the whole point here is that we're having fun just hacking on stuff and trying to see what works. Some of the ideas that I have for this is like live rendered scenes. So maybe a scene would have like, dynamic graphics happening maybe while I'm talking something, I don't know. Video filters to change how things look, generated graphics on screen. So like the lower third little pop-ups, I could make those happen dynamically. Viewer interactable components. We could have like games on the stream basically where you and the chat are doing things and it causes stuff on the screen to happen, which might be kind of cool. So there's all kinds of stuff we could do on the streaming side as well. Also, I don't have to write my own streaming software to do a lot of this. In fact, OBS allows you to write native code plugins where you can just, have your own custom source that gets pulled in, and I could do a lot of the same stuff with OBS itself. But I might look into how difficult that is. It might not be difficult at all. It might be pretty easy, but I do have the ambition to write my own streaming software at some point as well. All right, so let me go back to the chat here, answer some questions, because there's a lot of people asking stuff, which I think is great. Thank you so much for participating. Canoe Ninja says, do you use title cycles? I don't know what that is. Alexander says, music production is nice. I miss those days when I was messing around with FL Studio on Windows. On Linux, I couldn't set up anything like I had on Windows. Yes, I agree completely. So my first experience with music production software was probably Fast Tracker 2 or a tool like that, where you have like the grid where you have to put in all the notes and everything and sort of play it. It's almost like coding in a way, where you have to sort of just sketch out all of the things that each channel is doing on every step of the song. So maybe a little while later, I figured out that there was a program called Fruity Loops on Windows that basically had a similar setup. It was more of a graphical interface and was kind of easier to use. So I started making music there and then transitioned through a lot of different programs over the years. But it's true that it's very difficult to have a really solid music production setup on Linux compared to on Windows, because all the software is on Windows or Mac OS, all the DAWs, all the really high quality plugins and everything like that. On Linux, there's a lot of stuff. In fact, at some point, maybe we can go through and kind of try out some of these things. There's a lot of different synthesizers, a lot of different effects plugins, a lot of DAWs and stuff. I've never found a setup that worked well for me, just like what Alexander said. It's always been sort of hit or miss. Even using a more polished tool like Ardour, that crashes for me every now and then. I've also been really interested in this new tool called Z-Rhythm, and that one also wasn't really working out very well for me either. So part of me writing my own music tools is to solve this problem for myself, where I can actually have control over the situation and actually be able to make things reproducible so that I don't have these problems on future machines. Let's see. Ashraz asked, is that the successor of the original Fruity Loops? Which one? Okay, so Ashraz asked, why not assembler, the true system crafting language? Well, eventually I will do that, because I started writing my own assembler in Scheme. So one day we'll get back to that. I think it'll be fun to get back to that in the future. Hi, Ch'tij. Nice to see you. Thanks so much. It's harder to see what I'm responding to when I don't have the chat on the screen, but it's so much better to not have my whole workspace taken up with the chat box. Let's see. Yes, Appenzel asked a good question. Will all those applications be separate, or will they be merged into one program, kind of like Emacs? So the goal is to have it be a program with modules that could be loaded in, so you could use them all together if you wanted to, or just a very specific thing if you needed just graphics or just audio or whatever. So yes, I do want it to be an environment where you can pull things in as needed to do whatever it is that you want to do. So building that part of it's going to be part of the fun, I think. Oh, now I see that this System Crafters logo is like right in front of my face the whole time. Do you see that hovering over the stream video? Hey, Minican. Nice to see you. Okay, so next slide. All right, so I'm going to answer the question of why. Why am I going to do this? It sounds like kind of a stupid thing to do, right? Well, unlike other people in the world, I mean, there's probably plenty of people like me, but typically what you see when you see people talking about programming in the world is like, I want to build the next big app. I want to build the next big web service that takes off and is able to get purchased by some other company. Me, I would prefer to build fun stuff that satisfies a creative itch that I have. And programming is sort of like the core of everything, in that if I want to do something in a particular area, I can write code to help me do that. So I enjoy programming mainly for the creative value and to see what I can accomplish. All the stuff I've been doing so far on System Crafters is mainly me talking about what interests me about, crafting system configurations, which there's a lot of programming involved in that, but I'm doing it all just sort of for my own ends. I'm not doing it for anybody else. I'm not building, Emacs configurations for enterprise customers or anything weird like that. I'm just doing it for myself. So the same thing applies here on this channel. I want to do a lot of fun stuff, and I'm hoping I can make it interesting enough that people will want to come back and continue watching and see things progress over time. So I really am interested in all of your feedback over time, either in the stream chat or in the comments, or via email, david@fluxharmonic.com, etc. Just let me know what you think. Let me know if you think there's anything particularly boring about what we're doing here, or maybe things that I could do to improve, because I want to make this fun. I want to make it a lot more engaging than what I've done previously, because I'm always trying to level up, the production quality of what I'm doing, and I'm hoping that what I'm doing here will actually help with that. So some of the things that I want to do that are part of the why is I want to be able to create background music and graphics for my YouTube channels. I've been meaning for a very long time to make my own custom background music for System Crafters. I've been using the same 4 tracks that I got off of CC Mixter for a long time. It's getting really boring and repetitive. I want to make some new stuff that will be appropriate for that channel, and something that people may actually want to listen to not in the videos. Like maybe you would want to download the MP3s or listen to it on Spotify or something. So I want to make actual music that is good quality and can be used for system crafters and also this channel. So I don't want to be playing this crap. Well, let's not call it crap. I don't want to be playing this music that somebody else wrote that I have no control over in the background on Flux Harmonic streams. I want to be playing the music that we've made, that you watched me make on stream here. So I think it's going to be a lot of fun once we actually get to that point. It may take some time, but we may take some shortcuts early on and maybe use a DAW like Ardor or something to build some songs first before we get to actually having all of the code written for the audio tools in the future. I would also like to actually produce a full album of music created with these tools. I have wanted to publish an album of music for a very long time, and I've never gotten around to it because I've never had a stable setup or the sort of focus necessary to complete a whole collection of songs that would be put together on an album of music. But I think that I have a good reason to do that now. I guess my first idea there would be to try to make some music that could be listened to sort of passively while you're working on code or doing any other kinds of focus tasks, just sort of some ambient, relaxing type of stuff. But I'll do a lot of other stuff in the future as well, including things with guitar and bass, and also singing potentially. I know this sounds crazy that I'm going to try to sing, but I'm going to do it. At some point in the future, we're going to be recording streams and I'm going to be singing on stream. It's going to be pretty interesting. We'll see how well I can stomach that. I've been in a band before and I've sang live in front of people, so I don't really have a problem with it, but on a stream, it feels a little bit weird, but we'll get through it. I also really want to design a unique streaming experience. One of the things that I noticed with really top level streamers is that it's not just them staring at the camera the whole time talking to you. They're doing something interesting, and they also have a level of production quality behind what they're doing that makes it really engaging. So part of what I do as I hate this phrase, but content creator is try to make interesting content, or provide an interesting experience and maybe something that you can learn from. And I want to just level that up a few times by building things that can help me accomplish the goals that I have for that. Also, I want to create free software games. I think it'd be cool to create a few games. I've been working on a few. Let's say last year, before I started System Crafters, I was working on a couple games in Scheme. Never really got to a point where they were playable and people would want to see them, but we will get there, I think, over time. A lot of what we're going to do for the video parts of the code will translate to game graphics as well, I think, because we're going to try to do some low-level OpenGL work at some point. There's a lot of work that I want to do with vertex shaders, fragment shaders, etc., to make high-performance rendering of various different things, and that would also apply to games. I also want to do some data-oriented programming, potentially. I don't know if you've heard of that before, but it's basically a very difficult kind of code design that makes the code very efficient on the CPU cache, which also is very important for games, because you need your games to run quickly and not really have frame drops and stuff. So we'll get to that at some point in the future. Like I said, this is going to be a long-term project, and I want to be streaming at least twice a week, every week, to see if we can make progress over time, because I want us to build something here. And like I said before, I just want to do all of this while making it fun and interesting to take part. And it's not going to be achievable in the short term, but that's okay, because seeing it be built over time, I think, is more interesting than having immediate results. So I don't know if you've heard about it. Let me just actually pull this up, because this is one of the inspirations behind what I'm doing here. Uh-oh, what's going on with Q browser? All right, don't report, go away. So, Serenity OS. So there is a guy named Andreas Kling who's been working on his own operating system called Serenity OS. And he basically started building it from scratch and documenting the progress of it on YouTube. So you can go to his YouTube channel, I believe. Yeah, his YouTube channel is linked here. So this is serenityos.org. Let me copy the link for this into the notes. So here we go, Serenity OS. I'll go back here and then org present. There we go. So this is a really interesting project because he's basically just starting from scratch and building up an OS and making it look like Windows 95, which is kind of cool because I grew up, using Windows 95, so I have kind of a little bit of nostalgia for that period of time. But he's taking it all the way where he's doing a lot of stuff from scratch, and now he's got a lot of people contributing to the project. And you can watch a lot of videos about it on his YouTube channel. And to me, what I want to do is go sort of the multimedia angle on a similar thing where I'm building up a set of tools from scratch to do this kind of thing. But it's not really so much for nostalgia's sake, but actually for, actual productive creative work and to see how far we can get with it. So if you haven't checked out Andreas Kling's channel yet, you should definitely check it out because it's very cool what he's been doing over there. What is that? Undocumented. Wow. Okay. Let me check the chat really quick. Did I miss Hyder's question earlier? Are you going to build your streaming tools from OBS or start more from scratch? Yeah, a little bit of both probably. We'll see how it goes. Appenzel says, to me, those tools sound very interesting. Yeah, that I'm interested in making these things. I think it's going to be a lot of fun. And I've never really had a reason to sit down and do it until now where I basically said, I'm just going to do it live on stream and see what happens. Purple G says, this is a big project. Much excited to see the progress. Thanks. Yeah, me too. Mini KN says, I've been playing around with GuitarX plus Carla recently. It seems like another rabbit hole to get into. Haven't been able to get good sound out of it just yet. Yeah. I played with GuitarX a bit, and there's another one like that as well. I think it all comes down to understanding how to put together the effects processors to get the right kind of sound. I've used other like really high quality guitar effects processors before, like the Axe Effects 2 and whatnot. And, they have really high quality digital signal processing, but in the end, it's all really a lot of the same concepts for getting good sound out of a guitar synth. So I'll try to do that as well with the code that I'm writing. Obviously, I don't know how hard it is to do things like, what do they call it? IR modeling, inverse reverb. I'm not going to say the name. Let's see. What is it? Anyway, there's basically a way that you can model the sound of existing guitar amps by taking a sample and then sort of using it somehow. So let's see, IR guitar amp. What does IR stand for? Impulse response. Okay, so yeah, it's basically a way to mimic the sound of a given amplifier setup. So I don't know if we'll go that far, but I'll probably try to write some of the effects that you need for like distortion pedals or reverb or chorus or flanger, all that kind of things. So it should be pretty fun to try it. It might sound like crap, but that's part of the fun, I think. I think that if things sound bad, it's more funny and interesting than if they sound great, I guess. I guess getting to great also is pretty interesting, but I'm curious to see how this is going to go. This is a big experiment on my part for sure. See ya, Ashraz. Thanks for coming. And also Ashra says, and for real-time audio, depending on the workload, yeah, definitely you need to have something that is very cache appropriate for real-time audio for sure. Okay, so, all right, so to accomplish all this stuff, I've got a very specific design in mind. I'm going to write all of the multimedia components in C or a similar low-level language to get the kind of performance that I want and the kind of memory management that's necessary for that performance. A lot of that low-level stuff has to be written in C. Now, that's going to make things a little bit more complicated because, like I said before, you don't have high-level data structures. You have to kind of do a lot of things yourself. But honestly, that's the point. Is you don't want to use some other data structure that you don't really have full control over for a high-performance code. You kind of need to know what the performance characteristics are and know how to maximize the performance benefit you get out of it and also memory usage. So we're going to try to write this up in C. I'm going to do a very sloppy job of it at first. It's not going to be great, but we will improve it over time. And we're going to try to use, typical tools like profilers and whatnot to help with that whole process. Also, I'm going to use Guile Scheme as the interactivity layer at first. So basically, we're going to use Guile as a way for me to invoke all this functionality that's been written in the C layer. That way, we can have source files for starting up given projects, like doing graphics or audio or anything like that. And because of that, we can check that into source control, and we can also do interactive hacking on the creative projects while the program is running. So I think it should be pretty fun. I've got some ideas on how to accomplish that, but we'll see as we go how to make it work. Also going to create an Emacs package to facilitate interactivity and rapid development. So obviously, if we're going to use something like Scheme, we're going to want a REPL. And I want to host the REPL inside of the sort of host program. I don't know exactly how I want to call it yet, but the core program that loads up all these modules for the different things that it can do, that program will have a REPL, and then it will get wired up into Emacs. But I need to make it set up in a way where it very quickly can recycle itself. So if I make some changes to the native parts of the code, it needs to die and then recompile and then start again and have the REPL automatically reconnect, so that we can have a very quick loop in trying things out. So that's part of what I want to accomplish, is just make a really quick feedback loop, so that whenever the code starts up again, we have that REPL and we can try things out interactively and not have to like write a bunch of C code just to try out what we just did. Also, use GNU Geeks as the orchestrator for development and distribute tools via a Geeks channel. This one is going to be pretty interesting because it will validate whether Geeks actually works well for this type of thing. I'm confident that it's going to work, but it's just going to take a little bit of time to get everything set up, I think. The idea being that whenever you have a particular project, let's say I'm editing a video. When I work on that video and I have a file that sort of describes all the edits, all the effects, everything that are going to be applied to that video or that sort of sequence that I'm putting together, in the future, if I've tried to load up that same Scheme file to reproduce what I had done on that video, if the tools have changed since the last time I edited that file, I might get a different result, or it might just crash completely. So the idea is that whenever you create a creative work with this tool, you should be able to export the list of channels pinned to specific commits and all the manifests of all the packages used, so that you can restore that exact same environment at the time that thing was created, so you can reproduce what you had done before. So using Geeks will accomplish that, but I need to make Geeks packages for all the stuff that gets put together inside of this project, so that we can use the functionality of Geeks to accomplish this goal. Also, there is the really useful feature called Geeks Shell, which was previously known as Geeks Environment. I think there's like been some new development to do this new Geeks Shell thing. And the idea there is that you should be able to create a standalone development environment for a particular project using Geeks Shell, where it pulls in all the dependencies needed to compile that project. I want to try to use that as the way that we stand up the environment for working on this project, and potentially all of the creative works that are produced from it. So we'll see how that goes over time. Not sure exactly how it's going to work yet, but we're going to figure it out. Also, I want to be pragmatic. Sometimes we're going to have to use things that already exist, libraries that already exist, just to get things started. The way that I look at this is that it's going to be much more interesting if we have some kind of output at the end of almost every stream. So like we have to accomplish something that's visible at the end of every stream, and hopefully it's like to serve a specific creative project that I'm working on. However, over time, I want to write more and more things from scratch. So I might have to use a library like, let's say, SDL2 initially, and then eventually write my own code that serves some of the same purpose I was using SDL2 for after I've already gotten some of this stuff working. So we'll try to take a more pragmatic approach, so that we don't just sit here hacking on something for 3 months before we actually see something on the screen. We want to actually get something working fast, so we can iterate and then decide what else we want to change about it or improve about it. Also, I want to license all the code that I'm writing under GPL 3.0. You may ask, why do that instead of some other license? Whenever you're creating something of value, sometimes it's good to protect it, either by making it proprietary or by making it toxic in terms of the licensing. So making things GPL 3.0 is a good way to sort of keep people from just taking it and running with it and doing a bunch of other stuff with it. Of course, I don't know if anybody would really care about taking this code and running with it, so maybe it doesn't matter. But for now, we're going to start with GPL 3.0, and maybe I'll switch to different license in the future if people think that it's necessary. I mean, there are some ways that this stuff can be useful for people to make games or make other tools with some of the core libraries, but we'll cross that bridge when we get to it. All right, so the starting point. This is where I want to start to get this project kicked off. We're going to try to do as much of this stuff as we can today, actually. So I want to get the basic infrastructure set up for the C core with the Guile Scheme layer. So basically getting the C program that is the core of everything, and then load up Guile Scheme inside of it so we can start interpreting Scheme code in it. I also want to set up an SDL2 window to start experimenting with graphics. So like I was saying before, or a few slides back, I want to start producing graphics for the streams, either static graphics like thumbnails or some animated graphics for the stream. So let's say you can see where my head is down here in the bottom right-hand corner. At some point in the future, I actually want to not have a green screen behind me all the time. I would like to actually have a background. And to do that, I would like to have some kind of outline around that part of the video that's animated that makes it look a little bit more interesting and cool. And I would like to generate or write some code that can generate such an animation for me. So I think starting with SDL is a good way to do that, because I can write the code for making an animation in SDL and then render out all those images to turn it into an animation, either in like a GIF or potentially a video using FFmpeg. So this is where I think we're going to start, because it's going to be pretty easy to get some results, especially by using SDL. And then, yeah, like I said, start building a graphics tool to make video thumbnails and stream graphics. So this is going to be pretty fun, I think, because I think, you know, in the first couple of weeks, we'll actually have some things working and we can start making stuff with it. Opensel says, GPL is great. LGPL perhaps for libraries. Maybe. I'll have to look into the semantics of LGPL again. It seems to me that you don't have to make your code GPL unless you change the source of the LGPL part of the code, which makes sense. Yeah, I think that's the way it works. GNU Ninja says, any plans for MIDI? Definitely. MIDI is very important for me as a person who prefers to make music more with a sort of electronic slant. I'm not really like an electronic music producer per se, but I like using synthesizers instead of trying to record everything with normal instruments, because it's easier to experiment with things and also to get very interesting sounds. So I'll use MIDI for recording, you know, chord progressions or melodies or whatever, and the software that I write is going to have to actually, you know, be able to read in and record and manipulate MIDI. So that will certainly be a part of this. Okay, so I've put together a task list for what I would like to accomplish today. I don't think that all of it is going to be possible, but we've got about, let's see, about 2 hours. So I think we can get some of this stuff done. I also didn't have a whole lot of time to get the environment set up beforehand. So we're going to find out really fast about whether I'm going to have to install some things with Geeks and see how it goes with the stream. But at least for now, we're going to get these things going. So the first thing is definitely going to be to get that basic C application that loads Guile Scheme, get that started so that we can try out some of this stuff. So I know that I can go to the Guile Scheme manual to find some information on how to do this. And as always, if anybody has any suggestions as we go along with this, please feel free to say them in the chat. I have no problem with people making suggestions or pointing out mistakes or anything like that. Okay, I don't want it all on one webpage. So there is a specific page of this manual. Not that one. I've seen this before. So let's see, programming in C. Okay, linking programs with Guile, linking Guile with libraries. Programming overview. Let's see. Man, I know this is somewhere. Let's see, C load Guile Scheme loading load paths. That's probably not right. All right, so let's try to go back to the program in C part here. Concept index. Let's see, lib guile, linking guile with libraries. Oh, program in C. How about that? Is that where we were already there? Okay. Linking programs with guile. Yeah, package config definitely. Okay, here we are. A sample guile main program. Let me copy this link here and drop it into the notes, just in case anybody wants to try it themselves. So there's a very simple C program here that basically includes libguile. I don't know how visible that is. Let me zoom in a bit. In fact, I will just grab this and drop it into a file inside of the project /code/ I don't even know what to call this. Let's call it Flux Studio for now, but it's gonna have to change at some point, I think. So we're gonna call it main.c. I got this problem with some customizations I made to Vertigo that make it do that. All right, so we created that folder. So what we have here, we're pulling in libguile.h. We have a main function that's the entry point for the C program. It's calling scm boot guile, which is basically how you load up the guile runtime inside of the C program. Pass along the arguments, and then we're invoking this inner main function here. And that's being run from within the actual guile environment. So I think this scm shell function is going to start a REPL. Let's see, which calls scm shell to process the command line arguments. Oh, okay, so it's like a command line argument parser. There's a way to start the REPL too. Let's see, is it in this page? We'll figure it out. Building the example with make. I definitely want to do this. I need to have a make file to make it easy to build this code. So let's go to make file here. Drop this in. We'll use GCC for sure. Package configs. So we're gonna use package config to pull the paths to the C headers and also the library path for Guile 3, which is great. Simple Guile, let's call this Flux Studio instead. So I'm just gonna replace everything here. Simple-Guile to Flux Studio. All right, so that's all changed now. At some point I need to get, let's see, Keycast. Does Keycast work now? Trying to see if I can get Keycast to wake up so you can see my key bindings. So now, this is doing an object file. I want it to compile to a program. Yes. Minican says, I think it's Monakai Pro, Spectrum, or Classic. This is actually Doom Monakai, I think. Let me actually check that out really quickly. It's Doom Molokai, whatever that is, if you can see that. Let me know if the font size is too small too. Okay, so Flux Studio. Okay, so it just takes the object file and produces the output. So let me just do this. I'm going to change this to main.o. We'll change all the paths of this stuff at some point in the future too. Main.o. I know I'm not doing this the most efficient way possible, but that's okay. And I also don't know a whole lot about make files, so we may have to learn some things about that here and there as well. So I don't know if I actually have, let's see, make. Okay, I have make installed. External command not found. So, oops. Let's go to projects, code, Flux Studio. Make. Okay. Where is make? Ah, okay. Gotcha. So I don't think I have make installed, so now we're going to have to install it. So maybe I'll just do a manifest.scm here. I need to go look at my .config/geeks/manifest/code and just sort of rip off this manifest a little bit to get things started. GCC toolchain, make package config. I don't think we need text info. Don't want all this LLVM stuff. We do want CCLS, but I don't need that here. File command. Maybe I don't need that. Don't think I need that. Don't need that. Let's just get rid of a lot of the stuff. So Guile, I do want. Guile SDL2. I'm not going to bother with the existing bindings for Guile SDL2. I think I might start from scratch on that. SDL, I do want, I don't know if I need GLU and GLFW. Let me just start with plain old SDL2. What is the GFX library? Some of this stuff is from an old project I was working on. I just have them sitting around. All right, so SDL GFX2. Let's see. Hey, Felipe, nice to see you. CMake would have been a lot easier to set up. I might try it at some point, but I know CMake is complicated in its own way. I want to pick something that works well with Geeks, so that I don't have to configure a build system for it. And you know, CMake is also a pretty fine option for that. But well, let me see. Did my camera fall a little bit? Let's see. Sorry, I gotta move this thing. So we'll try CMake in the future. Makefiles are kind of a pain. Gon says there are a lot of implicit rules that take care of that nitty gritty. I would like to do that at some point for sure. But for now, we're gonna do things just raw to get it working. SDL GFX provides graphics, drawing primitives, rotozoom, and other supporting functions. I think I might want that for now, so let's keep that in. TTF, we'll keep that in too. So let's just do that for now. We'll get rid of these two. Why is Lispy not working? Oh, I see, okay. So delete that. Let me just delete this as well. And then I can delete that. And that should be enough. So GCC toolchain, make, package config, Guile, etc., etc. So I'm gonna pull up a vterm and I'm gonna try to use Geek Shell because I haven't done this yet. Geek Shell, I wanna load a manifest with it. So I think there's like a -m. Yeah, -m. So let's try Geek Shell -m manifest.scm. In fact, I think if I have manifest.scm, it picks it up automatically, which would be even better. I don't have to even think about it. Yeah, so -q inhibit loading of geeks.scm and manifest.scm. So let's just try Geek Shell. All right. So error, not loading because not authorized to do so. To allow automatic loading when running Geek Shell, you must explicitly authorize this directory. Wow. Okay. Well, that makes sense. That makes sense. Let's do that. Okay. So now let's run Geek Shell again. And now it seems to be consider passing the check option once to make sure your shell does not clobber environment variables. I'll try that because I don't want things to get mixed up in here. So let's see how this goes. It's going to install some things. Hopefully it won't take too long. The stream is not sponsored by Coca-Cola. All right, so now I should be able to type make here. Missing separator, did you mean tab instead of 8 spaces? What don't you like? Was it this? Ah, that need to be a tab character? I don't even know if that's literally a tab. Let's try this. Okay. All right, cool. So I think Flux Studio. Oh, okay. Yeah, obviously that. Okay, so it dropped us right into a REPL. So that was easy. We now have a Guile 3 REPL directly in our C program, which is a nice starting point. I guess the question is, do I want it to start in a REPL all the time? Probably not. But it's fine as a starting point for now because it will make it very easy to restart the program and host it as a REPL. So I'm curious to know if I jump out of, let me start up another vterm. If I were to run Flux Studio, does it still work? Okay, I'm thinking that it probably bakes in the library paths of the libraries it was built against. Do I have LDD? No. Is that right? Let's go to the code manifest. glibc, okay. glibc. So I can use glibc to use the LDD program to see what libraries are linked to this program. I just want to check it out really quick to see what there is there. Yeah, so it's directly linked to things in the GNU store, which is great because that means that I don't have to be running this from inside of the Geek Shell environment to make it work. That's a very good thing. So I'll get out of this. Let me just get rid of this annoying song. Cool. So make needs tabs, but Emacs should handle that correctly. Yeah. It did whenever I went and replaced the characters. All right, so now, let's see, what's the next step? So we got that loaded up. That took a lot less time than I thought. Let's go back to our org file. So, in fact, I'll get out of presentation mode for this. Let me kill the panel. All right, so this is done. So we've loaded up the Guile Scheme engine. Start a REPL and get it loading inside of Emacs. So that's the sort of the key point now. We need to load this up inside of Emacs. The easiest way to do that would be with, GNU Ninja. I saw that too. Flux Studio is a thing already. This is why I'm hesitant to use that name. I'm going to try to find a better name for it, but I just haven't thought of it yet. Totally open to having suggestions made from the audience on that as well. So, the easiest way to do this would be to use Geyser. Ultimately, I don't want to use Geyser for this, but it's a fine starting point. So what I'll try to do is set a directory local variable for Geyser, let's see, Guile binary. Yeah, Geyser Guile binary. That's going to let me use Flux Studio as the Guile binary instead of the normal Guile binary. So I will set go back into the code, set a directory local variable. Oh, come on. I think it's add directory. What is the, okay, add dir local variable. So we're going to add it here. We're going to say Geyser Guile, what? Oh, mode. Okay. This is a scheme mode, right? Scheme mode. In fact, probably want it in everything, but let's just do this right now. Geyser Guile binary. Okay, so we're gonna set this to Flux. Whoops, not Glux. Flux Studio. All right, so now we've got this. I think if you put nil here, that works better because it doesn't specify a specific mode to turn it on with. I don't really care too much about it being just for scheme mode because there may be other reasons why we want it to be set elsewhere. Oh, this needs to be a string. So let me just put this as a string really quickly. And now if I go back into, well, let's see. What I would probably like is to automatically load a particular init file, like init.scm. And it does pop up with the local variables list stuff. Apply the local variables list, permanently mark these values as safe. So this never works for me because of the way I have Emacs set up, but we'll just do it anyway. So we have init.scm, and if I were to say Geyser, run Geyser, start a Geyser REPL, I also need to set what the Geyser scheme implementation, active implementation. Set this buffer local variable to specify the scheme implementation. So I need to set this to Guile. So let me actually set that too. I wonder if there's a way, hold on. Can we do this with, what's it called? Embark, let's see. Geyser scheme implementation. So I'm gonna press, I think I have it set to Control D, no. I don't have it set up right, okay, whatever. So let's go back to dir locals and we're gonna add Geyser scheme implementation and we're gonna put that as Guile here. Because we want Geyser to automatically try to run a Guile implementation. It has some stuff that it tries to load in based on the implementation that's being used. So we'll go back to init.scm. I'm gonna run normal mode. I think that's how we can re-invoke those variables. Let's check Geyser scheme. Okay, so it's set to that. And now I'm gonna run run Geyser. No such file or directory Flux Studio. Okay, so the current directory needs to be set. Maybe I can put that as a full path. So Geyser Guile binary name to use. Can this be a full path or no? What's the default value? Nothing. So I think probably there's going to be Geyser. Let's see. Return the name of the binary to execute. I'm trying to see how it grabs the path. Is it just like expected to be on the path? That would be kind of lame. Geyser Guile Scheme Deer. Directory where the Guile Scheme Geyser modules are installed. That could be interesting. I may have to set it to the, let's see. Let's close that window. Let's jump into Deer. I don't know where the profile gets stored for the Geeks shell. It's probably getting stored somewhere in Geeks. No. Geeks profile. Jeez. All right, let's not worry about that right now. We will have to worry about that at some point, though. We're gonna have to set the load path correctly. All right, so we still need to find out where. Let me heart this song. It's kind of nice. It was the previous one. Whatever. Okay. Geyser Guile load path. I don't want to listen to this sad music. So the load path, we found that Geyser Guile binary. Geyser implementation, binary Guile parameters, Geyser Guile startup. Let's just take a look at this. Arg list. It's really weird. It doesn't give me a way to specify the path where the binary can be found. I guess it just expects it to be on the paths, which I can do. So maybe what I should do then is change the makefile to put the program output into a bin folder. I don't know if this is the right way to do that with make, but we'll find out. Let me just mark these two here. Mark these, delete them. So now if I go back into the shell, my vterm, and I run make. Okay, so no such file or directory, so you have to make it first. There must be a way in make. What? Cannot find bin. Okay, so maybe I actually have to set that in a make file. Is it like this? bin/make or main.o. And the output folder. So gcc -o, place the output into file. Can you just tell it a directory though? Let's just try that. -o, then bin. Probably not gonna work. If anybody knows the answer to that, let me know. Cannot find, let's see, gcc bin main o. Create a build directory for the output. Yeah, I'm trying to do bin for that right now. We'll kind of polish it up later, but you see main o. I wonder if there's a way. bin/flux studio. Okay, let's just do this. That doesn't work either. Okay, so ls bin. Nothing is in there right now. Main.o got dropped into the main output folder. Let's just move this. I don't know if that matters. We're gonna run make. Why does it do that? Oh. What is it? Okay, I think that's the problem. Okay, so there's main.o, rm main.o. This is definitely not very nice to people who know what how to use make files. Okay, so make dir bin. Okay, so they seem to be getting put in the right place now. That's good. Okay, so we have a separate folder for that, which is good. Now let me remember why we did that, because I don't remember at the moment. Well, obviously to keep it clean to start with, but I also needed to make sure that I gotta set the load path. Oh, I want to add it to the path. That's why. I think I want to add the bin to the path. So, is there a way in Emacs dir local add to path? There must be a way to do that. List concat root headers. So Emacs dir locals add to list directory variables. Yeah. There must be a way to do this. You know, There's a way to eval something, so maybe that's the way to do it. Is there any other variable I can use for this? Path. I know that's not great. Exec path, list of directories to search programs to run in sub-processes. That could work. Element is a... By default, the last element of this list is exec directory. Is that set to something by default? Okay. Something. Okay, so let's actually check and see. Emacs dir local exec path. Has anybody said anything about that? Add dir local, no, use data pair notation to write a list of variables dir locals.el. Let's see. Dir local variable. That's nothing. Not useful. Okay. There must be a way to do this. It has to be a common problem. And, you know, I probably covered it myself at some point. I just don't remember it now. All right, let's try this. Let's go back to dir locals. Dir locals eval. Emacs, I forgot. Evaluate values in dir locals. Eval pseudo variable facilitates evaluation in local variable configurations. If you're setting variables in an eval form, take care that you're setting buffer local values. Use at set q local. Okay. Does add to list add to list? Does that have a local? Does not seem to have a local. Is there a add to list local? No. Okay, I'll just have to do append myself. That's not a big deal. GNU Ninja is suggesting Fluxus Studio. That's interesting. Eval. Okay, so eval, and then I can use a progin or whatever I want to set values. It's not great, but, you know, right now it will work, I think. So let's go here, and it's eval, right? eval. Ugh. Yeah. Okay. Eval dot, and then I want to use setQ local exec path, and I'm gonna append. What does append give me? Sequences. Okay, so list of. Oh boy. I want to make this. This is evaluated. Does it actually have default directory set? Probably. So let's go with. Was it concat? Concatenate all arguments to make the result a string. All right, so we're gonna concat. Come on, dude. What's the problem here? That's weird. What is happening? Lisp data. Okay, Lispy mode. I need Lispy now. And Lispyville, I think. Okay, I think I have it hooked. All right, fine. All right, so let's go right here. We're gonna concat bin to default directory. So let's actually try that right now and see. There's probably another function I should use for that, but it's not gonna matter too much. Oh, okay. So I can take the slash at the front off. All right, so Flux Studio bin, that works. And now if let's see, append, we're making that a list. We're putting that at the front. And then we're gonna use, get out of my face. Jeez. Okay, so exec path, right? Is that right? That's a function. Okay. So I should be appending that to exec path and then setting the local variable for that. Is exec path already a local variable? No, that's okay. We're gonna make it one now. All right, so I'll save that. I'll execute it. Let's actually check what exec path has in it. Maybe it got reevaluated now. Not yet. Normal mode. Now let's run this. Okay, that seems to have worked. Cool. So now if I were to run run geyser, still says no such program or directory, which is weird. Because let's see what eShell tells me. So I'm gonna go back into eShell. I'm gonna cd to the home directory. I'm gonna run flux studio. All right, so that's not working. But if I were to copy this code, let's just see what happens. Just trying to verify this actually would work. So I will just make this a raw string, I think. Will you not let me use, God, okay, whatever. Let's just do it the hard way. So home, Davey Will, projects, code, Flux Studio /bin. Make sure these line up. Pending, let's take that off. Let's join these two. All right, so now exec path should be able to get set. All right, so now if I run Flux Studio, does it not get the executable bit set? Let's go to here. Let's go to vterm. So bin. It's got executable bit set. That's weird. CD bin. Obviously, I'm doing something wrong here. Oops. Flux Studio. Okay, so that works. Go back to eShell. Exec path has the whole path in it. So long as I wrote that path right, I'm pretty sure I did. Projects, code, Flux Studio, your locals.el /bin. So maybe exec path doesn't actually work the way I think it does. Exec path. There is also a function add to path. There's a path manipulation function somewhere. All right, so Emacs add to path. This is probably not going to give me the result I want. Exec path, okay. Appenzell says, in that case, Fluxus suite might be worth considering. Suite set of musical pieces considered as one composition. That's actually not a bad idea. Suite is kind of a cool way to call that. Gon says padare. Okay, so. Oh boy, that sounds like. Why are we listening to things that are not part of this playlist? Now I'm starting to play things that are owned by Nintendo. That's not good. Let me just throw this on repeat. Can I do that? All right. So. Hell World. Okay. Set in path. Maybe that's what I need to do. So I'm not sure exactly what I'm not sure what you know, that's probably what's happening actually. It's like the environment path is the one that's not getting picked up. Value of environment variable path is used by Emacs when you're running a shell in Emacs. Similar to when you're running a shell in a terminal, exec path is used to define programs it needs for its features. Okay, so that is a big difference. So how about we do that? It's kind of bad to have to manipulate the path, though. I really wish they would let me set the path where the geyser, let's just see, geyser load path. That's not it. Okay, so how about this? Emacs set path for geyser implementation. Okay, setting racket geyser Emacs path. Okay, that's good. Okay. So apparently you just put the whole path. Okay, great. That works for me. In fact, that's easier. So let's go back to dear locals. For geyser guile binary. In fact, what we could probably do here, I don't know, can I run code as part of that? I would think not. I don't want to waste time, so let's actually just do this. We're going to set q local geyser guile binary. We're going to do exactly what we had done before. Run on Lispy mode again. And instead, let's drop that here. Geyser guile binary, and then Flux Studio. And we don't need to do this any longer. We can take this whole list part out of here. This pinned out as well. And that is probably it. So we just need to set this variable locally. Okay, so cat default directory Flux Studio. Let's try that now. I'm gonna go back into init.scm. I'm gonna use normal mode. I'm going to check the value of geyser guile binary. Okay, so now run geyser, boom. Okay, so now we have the Flux Studio binary running as a guile REPL inside of geyser, which is great because now we can actually start running code directly inside of that. So if I were to say like define hello name, what is it? Display. Concat. I'm getting IntelliSense or code completions here, which is nice. Concat. String. Okay, string append. String append hello name. And then we also want to put a new line at the end of that. All right, so if I were to use, what is it, Control C. Oh, come on. I'm not getting my embark prefix help. That's great. So if I look at describe bindings, what is eval last s expression? What about, is it, okay, there we go. Control meta X, same old stuff. Control meta X, all right. And if I were to say hello Fluxers, and then use Control X, Control E, then it does write it out. So we are in a REPL, an active REPL, where we can evaluate new code, which is awesome because now we can actually do some of our own interactive stuff, which is great. Okay, let's see. Flux compositor, that's cool too. I like that. That's kind of nice. Bakery says, what are you making? Right now, we are setting the groundwork for everything else we're going to be working on in these streams by creating our own C program that can load up Guile Scheme, or at least the Guile Scheme runtime, and start a REPL so that we can start working on both sides of the code. One side being the native code in C for doing all the low-level graphics, and also the scheme layer, which is going to sort of drive everything when we start to use the C code to create stuff with it. Okay, so now I'll just delete this out. We have this file called init.scm. I'm actually kind of interested to see, let's see, display, this is a test. I want to see if I can launch this init.scm file after. Let's get rid of some of these windows we opened. Okay, that was everything. So we'll go back to the Guile Scheme manual. Guile Scheme manual. You know, it'd probably be better if I loaded this stuff up in Emacs. Let's try that out really quickly. So info, Guile. There's probably another way to do that too. Guile. Guile library, no. Guile reference, okay, that's it. All right, so we have, I think it was the programming in C section. There's also API docs somewhere. Linking Guile with libraries. Sample Guile extension, I don't want that. What's the, man, I really need Embark to work. Let me just see if I can fix that really quickly. I need to be able to see what my, is it, oh, okay, require Embark, is that the problem? Okay, probably that's the problem. Let's kill that. So G, control H. Oh, come on, man. Where is help command? That exists. Embark, help. I just have an old version of Embark. Is that what's happening? I'm pulling it from straight. Yikes. All right, let me see if I can update that. Straight pull. Let's try this, Embark. We'll see if we get a new copy of it. I don't know if it's gonna work. Gon says that setting the path will prime the path for the child shell. Yeah, definitely we'll do that. All right, so if I were to require Embark again, probably it's not gonna work, is it? Oh, maybe I need a straight build, rebuild package, Embark. All right, so can I require Embark again? Embark, help. Prefix help command, great. All right, so let me get rid of this again. G, control H. I just need to remember the keys to go and navigate around. So next and previous. So let's say, nope, that's not it, is it? Like a history? So like a back? Rev reference, next reference. But control C, control H. Nope, okay, whatever. So I'm gonna go, let's go up to, come on, I wanna go up. API reference, okay. API overview, initialization. Okay, cool, this is the place we wanna be for sure. So I think SCM shell is in here. Yeah. Okay. So process command line arguments in a manner of the Guile executable. It includes loading the normal Guile initialization files, interacting with the user, or running any scripts or expressions. See invoking Guile for more details. Well, I don't really need to do that. So I will go to Let's see. Utility functions, no. Input and output, read, eval, load, compile. Okay, so if I want to read a file, loading scheme code from file. So I probably do want to set the load path so I can load up the init file. This is my own init file that's going to set up the environment. Load file name. Okay, so it's just a scheme procedure. I need the C API for that. Usually they provide that. SEM primitive load. Load the file named file name and evaluate its contents in the top level environment. Must either be a full path name or be a path name relative to the current directory. Taking a C string instead of an SEM. I need that. So let's try SEMC primitive load and see if we can load up our init file. Just to see if we can set things up a little bit. Main.c. And then I'm going to go into this inner main. Before we run the shell, I'm going to use SEMC primitive load. I mean, Guile has its own ways to do this stuff, I think, but we're going to use our own internal way to do it as well. So /init.sem. We'll probably have to change the path for this. I don't know if I need to do like a /o at the end of this, but we'll see what happens if I just give it a string directly without any kind of stuff at the end. So we'll go back to vterm now and then run. This is the wrong one. Let me exit this one. Go back to the other vterm and run make. Whoops, make. Okay, so it did make it. And if I were to run bin/flux studio now, let's see, no such file or directory /init.sem. Okay, that's a start. Whoa, what just happened? No such file or directory ls. I broke something real good. So init.sem is in the Flux Studio directory. That's interesting. Is it just the current directory? Maybe if I were to delete that part off. Let's try this. Make. Okay, so that did write out the string before the banner showed up here, which is cool. Wonder if there's a way I can make it not write out its own banner. I don't really want it to write this out. I mean, I guess it could, but I'd prefer it just to be my own banner, I think. So SEM boot Guile, then SEM shell. SEM shell seems to be the one that is invoking that. So if I go back to the info, I go up, 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 and well, actually, maybe I do want to go to the API reference. I'll go there and then initialization again, SEM shell. Loading the normal Guile initialization files, interacting with other user running scripts. Does not return. You can do all application-specific initialization before calling this function. So invoking Guile. Let's see, no debug. See, I would have to basically inject these into the list of parameters, which I kind of don't want to do. I suppose I could. But that's another wrinkle when dealing with C, is you have to figure out how to do list or array manipulations like that. Teach says Fluxy Lady. All right, so that's fine. We'll just live with the thing for now. What we did see though is that it did allow us to load our init.scm file, which is great. Gon says, does that have to do with the LD library path? I'm not sure. I don't think so. Not for that particular part, if you're talking about loading the script files. Let's see, is there a way to set the load path, I wonder? That would only be necessary for modules, so I will ultimately need a better folder structure for this, I think. Something that will allow me to separate the scheme and C code, and then add the scheme modules to a load path so they can be imported correctly. So let me just think about that for a second. I hate that I broke ls somehow. Exact path. Let's see. What if I jump back to... Let's try this really quickly. Let's do this. Okay, that works fine. If I jump into Flux Studio, it's busted. That's great. So did I already set? Can I kill that one? Let me kill that DRED buffer. Go back to dir locals. We're not setting that anymore. In fact, let's delete that too. Now if I go into this directory, okay, good. At least we have DRED working again. So basically what happened there is that I had set the exec path variable previously and somehow managed to break DRED. It couldn't find ls anymore, so I had to go kill that DRED buffer so it could be regenerated using the newest value of exec path where I haven't actually been messing with it. That's the reason why we set that as a local variable, a buffer local variable, so we didn't have to worry about it propagating to my Emacs session and breaking everything, which is great. Okay, so what I want to do is have some kind of source folder set up here. And this is going to get more complicated. It's going to make the make file a little bit annoying to deal with, but that's not horrible. So I can start with a folder called src for source. And then trying to think of how I would name the different parts of this. Obviously, I could say modules for the scheme part because it is sort of a module path. And then for the C side, I could call it core. So we'll go with that for now and see how it shakes out. And now what I'm going to do, let's load up main.c. I'm going to kill that. I'm going to take this file, actually rename file, main.c, and I'm going to put it into source/core/main.c. All right, so now that should be there. Okay, that's good. And now let's update the make file. And we're gonna take this out of source/main.c. All right, and that should still build. If we kill that, run make, no rule to make target main.c. Okay, we need to change this. So make files are very specific about the paths apparently. No rule to make target /source main c needed by bin main o. Oh. Why is this even here? It shouldn't be there, should it? It shouldn't have a dependency. Yeah. bin/star. Okay. Source/ oh, okay. All right. That's why. I put it in the wrong place. Source core. Okay, does this work now? Are you happy? All right. Cool, that worked. All right, so now we've moved the source around a little bit just to have a better layout, just to have something a little bit, more expansible. And even in this place, we could have like flux, etc. Make directory. So now if we look at our modules folder, there's a flux folder. Dan says core, etc/core. Yeah, either of those could be fine. All right, so now let's see what's next on our little agenda here. So we've got an init file loaded up. We don't really need the init file just yet, but it's good to know that we can have something loaded into Scheme at runtime, loading Flux Studio. We're just gonna call it that right now. A couple of new lines. All right, and maybe I'll add that as a to-do for another time. Let's see. Next steps, we're add a to-do for don't show Guile Scheme banner when starting Flux Studio. And basically how I'm gonna handle this is I'm going to sort of copy forward the tasks that we didn't complete to the next stream so we can keep working on stuff, and might have like a backlog file somewhere. All this stuff is gonna be on fluxharmonic.com. so you can check all the notes out from every episode and see what you might have missed. All right, so set up a REPL and get it loading instead of Emacs. We finished that. That's good. Set up SDL so that we can start drawing things to the screen. So that's going to be pretty fun. Gavin says, making the animations for the streams in Guile. Well, I'm going to make them... yeah, we're writing the code for the rendering in C, potentially. And then we are going to use Guile as the language to describe the stuff to be drawn, I guess you could say. Gon says using makefile variables makes it avoids extraneous typing. Send me a link. I don't know if you can put a link in the chat, but if you can point me to that. About the makefile, okay, Ashraz is jumping in the save today. Instead of source core stands for all dependencies. Okay. Which part do I put that on though? All right, let's get back to it. We're gonna set up SDL now. So SDL2 documentation. I don't know if an info file got set up here. No, probably not. SDL2 read the docs. Let's see. Introduction. And you give me like a getting started app really quickly. Might have to do this in a separate thread too. Migration guide, yeah. Give me a main.c, please. Get the source code. No, I don't want that. Tutorials, thank you. Okay, let's just go to the wiki. That was a wiki. Okay. No, I don't want to download a file. Put it in the cc command. Introduction, source code, installation, tutorials, articles, books, facts. Yeah, okay, whatever. Let's get it going here. I already have some experience with SDL. I was trying to avoid going and just ripping off my own old code and just show me like trying to figure everything out from scratch, but we'll see how that goes. That's not very well organized. I swear, I've seen a much better laid out wiki before. Is this the right wiki? Link your program against it. Source dir equals module source, and then foo equals source dir. Okay, yeah. That's probably the right way. Thanks, thanks, Gon. Ashra says in the compilation line, need to see the makefile again. Also, programming something in C++ on the side, so I'm slightly distracted. Don't worry about it, man. I appreciate that you're here, even listening to me babble on about this stuff and helping me. Hey, all the people who are suggesting things, I'm very appreciative for that every time, because it's a very weird experience streaming yourself trying to code something because you're trying to solve problems and also talk at the same time. So having suggestions also is very helpful. Supported platforms, blah, blah, blah. Yeah. We know all this stuff. Give me a C file that I can just steal. All right, here we go. SDL2 main.c. There must be a repo that has all the samples in it. There we go. SDL basic tutorial main.c. All right, I remember that. SDL init. We're creating windows, surfaces, rectangles, the main loop. This seems like a pretty decent starting point, so I'm just going to rip this off. Of course, let me double check the license of this repo. Is there a license? No, there's no license. Yeah, okay. I'm not going to take that code. Sorry, guy. I mean, if you want people to use your code, you need to make sure that you provide a license so we know what to expect. All right, okay. Ashra says, that's live rubber duck debugging. The viewers are a flock of rubber ducks. Well, it's a very helpful group of rubber ducks, I have to say. Let's go. Let's get this started. All right, so for those of you who've joined more recently, basically I want to get a simple SDL2 window running so that I can start drawing some things to the screen as a starting point to make graphics that can be used for thumbnails or for stream graphics, animations, etc. SDL2 getting started. You know, I've got some code somewhere. I don't want C++. Okay. Image viewer, nice. Showing an empty window. That works. That's enough. Just get something on the screen. Okay, well that's good. So, you know, this is a blog post, so I'm gonna assume that it's relatively safe for me to take code from here. I probably don't have to be that worried about it, but you know how things are these days. Okay, so I'm gonna go to main.c. I actually don't want to do this in main.c, but we're gonna start somewhere around there. Make file. Okay, yeah, I don't have the file open right now. Core. So we're gonna drop this code in here, and this is not the right place to put it, but we will use it as a starting point to build on. So let me get this going. I'm just gonna move some of this stuff around a little bit. This is not the main function anymore. So one issue we have here is that the REPL has to run on a separate thread as I suppose you could say, the SDL code. So I need to figure out a way to do that effectively, because I haven't dealt with threading inside of C. Let's see, C create thread Linux. Pthreads is probably the way to do that. Okay, great. How to create threads in Linux with an example C programming. Pthread.h, of course. Hello, let's go. All right, we're gonna put pthread.h in here. Pthread self. Okay, just show me how to create one. Thread creation. And also, for those who are wondering why I don't just use the SDL2 bindings for Guile, because there is already a complete binding, I think, for SDL2. I don't want to tie this stuff to Guile so much. I mean, Guile is going to be the interface for it for now, but I would prefer to have my own core be written in C so that I can change out the language that gets used for it at some point in the future if I want to. All right, so here we go. Pthread create. What is this TID? Thread IDs? It's like okay, so we're basically creating a data structure to hold that. Hey, Benoit. Pthread create, yeah, okay. So we're just gonna grab this really quickly. And we can check the error for that. So I need to boot Guile. Oh goodness, there's a phone ringing in this room right now and someone's gonna have to come get it. All right. So I'm gonna drop this pthread create right here. This is not the best place to put this, but we're just gonna put it here as a starting point. So create the thread for SDL2. In fact, let's just do this. The pthread create stuff will be fun. Yeah, we're gonna find out real fast. In fact, I think SDL2 has some threading stuff built in. Hold on a second. SDL2 thread. I'm pretty sure that they have helper functions for this. SDL create thread. So, you know, I hesitate a little bit to be dependent on SDL for that, but for now, maybe it's not a big deal. Let's stick with pthread and just see what happens. So, I think I need to have a separate function. Yeah, I need a function that the thread is going to invoke. So let's call this init SDL, which is great because we call SDL init as the first function there, so it's not confusing at all, obviously. Let's see. Int init graphics. This is terrible. Really bad function names, but we're just going to go with it for now. So that was an array. No. So let's see. An array of TID, pthread API documentation. Oh dear, POSIX thread fun. Yeah, we don't really have a choice because I'm going to have multiple threads to have Guile running somewhere else. The only other option is if I can tell Guile to run on another thread somehow. I mean, I guess technically speaking, it's supposed to do that. Does SCM? Okay, let's try this really quickly. Let's do another thing before we get too far into this. I'm gonna go back to the info. I'm gonna go up. API reference, initialization, SCM boot. So let's see, is anything about thread here? Okay, each thread that wants to use functions from the Guile API needs to put itself into Guile mode. Wow. Global state of Guile is initialized automatically with when the first thread enters Guile mode. Okay. When a thread wants to block outside of a Guile API function. Yep. Yeah, what Ashra says is true. SCM with Guile, call function, passing it data, and return what func returns. Yeah, getting into threading is going to be a headache to start with. I'm trying to think. Is there a way that I can invoke this from inside of... maybe that's the way to do it. I guess bring it up to the level of scheme might be useful, because I can just let it be part of what happens in the... Guile thread. So if I did that, then the loop for what gets rendered needs to run in the Guile code, or it needs to be invoked from the Guile code. It could be a C function. But this is the part of the stream where I start thinking and I don't say anything for a while. Because it's hard to think and talk at the same time. So here's what I'm thinking. The constraint that I have right now is that I want to make the rendering code for graphics at least be somewhat declarative. So it's not like you have to have a render loop set up inside of the Guile scheme code. You shouldn't have to have a render loop. It should be more like declaring an overall data structure that is going to be rendered. So it's like retained mode rendering. I think that's the right term for that. Let's see, retained mode rendering. So you basically build up a scene graph of some sort, and then that gets rendered out by the rendering loop. Let's see, the graphics library retains the scene. The client calls into the graphics library and does not cause actual rendering, but makes use of extensive indirection to resources. So the reason why I kind of want to do it this way is so that the actual scheme code is more like the blueprint for the thing being created rather than the actual code. Because otherwise I would just write, normal SDL code in Guile. I do want to make it so you can use functions and whatnot as a higher level abstraction for generating parts of what goes in there, but it shouldn't be necessary by default. So to get back to the point of that, having the SDL loop run inside of the Guile thread makes things harder, because then the code has to have some kind of lambda function that gets passed into another function to be invoked as part of that loop. And I don't want that. To make it more correctly declarative, it would be better if you didn't have to deal with like a callback. which you would need if you were running it from inside that thread. So we do need 2 threads, I think. At least for now, we need 2 threads. And that's going to make things more complicated, but this, when you're writing this kind of code, you kind of have to go the complicated route. So let's go back to the POSIX threading APIs. I want to see what the actual signatures are for these functions so I can understand how to use them correctly. Okay, there's some IBM docs. It could be okay. I don't like all these cookie notifications. Come on. Why is this not increasing in size? There we go. Information about pthread API examples. Do you have any examples to show me, or is it just information? All right. Thread management APIs. All right. So pthread create, is that in here? All right. Creates a thread with specified attributes and runs the C function in the thread with a single pointer argument specified. Okay, cool. So pthread t, it's a pointer to a pthread t struct. Some attribute, the start routine, which is a pointer to a function, and then the arbitrary pointer to any argument needs to be passed in. The function pass start routine should correspond to the following C function prototype. That makes sense. If the thread attributes object is modified later, the newly created thread is not affected. If attribute is null, then the default thread attributes are used. Okay, that's good to know that I don't need to do that. Okay, cool. This is a little example. That's nice. All right. Great. Let's just steal that little snippet there. And init graphics, let's just do this. Whoa. Why did it drop it? Okay. This probably needs to be here, little global variable, which is always nice to have. And then I can, is it creating more than one? I don't need an attributes, at least not for now. So let's just do that. Foo. We're gonna use this init SDL instead. Let me just drop this down here. Don't need this attribute init. All right, so now I'm just gonna use init SDL. And then let's change this to a void pointer and then void pointer arg. I think that's right, right? Ah, really? There's like an info manual for that. That's great. I'll check that too. Okay, so void foo, void, and t. Let's move this down here actually. Okay, so we have graphics thread handle. We're gonna improve our C programming skills over time, I promise. Right now it's kind of gross. Okay, so in the actual SDL init part of this, or the init SDL function that we're gonna be calling, and do I need to? It's weird that I don't need to have a reference character for that, but anyway, we're calling SDL init. We're creating a window. Let's actually just do this Flux preview. We don't care about the window position per se. We're gonna do a 640 by 480 window. Let's bump that to 800 by 600 for now. Come on now. All right, so then SDL quit, we don't want to do that yet. And the interesting thing about that is, let's start our while loop. Actually, let's see, where is my SDL? Okay, so is there a loop? Anybody got a loop here? Great, that's what I need right there. I just need this little while loop as a way to keep that thread alive. What is this song? Okay, so at this point, I'm going to drop in a loop that's going to wait for, let's see, what is that quit variable? Is this something they defined? Bool quit. Okay, bool quit equals false. So then we're waiting for events, and then if the event is a quit event, brushing off the rust in C. That's basically what's happening here, for sure. All right, so that's a plain loop. That's kind of nice. We will see how that goes. And then whenever the event comes in, it will quit. So that's probably good enough. Return 0. Yeah, 0 is fine. I guess I could just do... I don't know if that's going to work. Let's just return 0. All right, so we got everything here to set up a window. I want to make that... Do I want to make that window... global? Let's just leave it like this for now. This will be fine. So back down in this part, we have init graphics, RC. I need to check that result. Graphics thread handle null. We don't want it to send attributes. We're sending the init STL function. So I'm going to call init graphics here, which is not really what I want to do at this point in time. I'm going to have to think of another way to do that. So init graphics. In fact, I think I want to expose this as a function through Guile. So if we have time, we're going to try to do that to see how easy it is. I think that's going to be pretty cool. Okay, so init graphics doesn't take anything. And we got a thread looping. We should see a window, and it should allow our REPL to still be functional. So I think I also need to go back to the make file and then set up STL also for package config. So let me double check STL2 package config. I remember this being a little bit weird in the past. Let's see. Okay, libs STL2. Okay, so let's just add STL2 to the list on both of these, and then run make. All right, so we got a problem here. RC is undeclared. That makes sense. I didn't declare that. Oh, I need to include standard bool. Great. At least the compiler told me that I made that mistake. We're gonna go back to, come on, main.c. Jump up here, put in standard bool. We should probably put, well, let's leave standard IO out for now. We don't really need that yet, I don't think. All right, so we've got standard bool in now, should be fine. And I need to define RC. So I was looking at a sample from IBM here before, I think. RC, where did you define RC? You didn't. What a nice little sample you created. I'm guessing that's an integer. Yeah, integer. Okay, so I can just say int RC, right? Int RC. And also I need to check the return value to see if, what is the result going to be here? Gon says, why not use heavyweight processes with fork weight? Because I need to have access to the same memory. Because the scheme code is going to have to write to stuff in memory that the C code has access to. I mean, you could do... you could do that if you wanted to. You would just need a protocol for sending information between processes, and that's a lot more complicated than what I want to do right now. Yes, Ashraz asked, why are we using threads? Yes, the Guile REPL, when you call this SCM shell function, it blocks the thread. Gon says you're not using LSP mode. No, not right now. Yeah, I should, but I have not set it up. Let's see, LSP mode. I wonder if I even have CCLS set up. Doing something. What did it run? CCLS. Okay, cool, good enough. Implicit declaration of function is invalid. That's not a declaration. Now we got a lot of angry markers now that I turned on LSP. SDL init video. Is that not defined? LSP, let's see. No definitions found. All right, we'll get to that in a second. How about this? Let's just run make again. All right, event is undeclared. What's up with all these samples that I'm copying wrong? SDL event. Okay, so we got these both set up. I need to go and copy this back too. I'll put that there. Save that. Jump down here. Make. Okay, so undefined reference to symbol pthread. I think I need to pull in pthread too with package config. What about package? Oh, maybe is that a library I need to install also? Okay, so let me check this out really quick. Pthread. Oh boy, where's that gonna come from? IPC is definitely another can of worms. Thread safe queues and channels. Yeah, that might be something in the future. I mean, we'll see. It would be nice to have an interactivity layer that wouldn't crash if the core layer crashed, but at this point, I think it's fine for them to be mixed together. Okay, so compiling, let's see, GCC compile with pthreads. Compiling C program with pthread library in Linux. Let's see what it tells me to do for that. Oh, come on, man. Whatever. Object all. Okay. Okay, so 0 basically says the thread is created successfully. That's good. Yep. LP thread. Is it there by default with glibc or something? LP thread. Okay, let's try that. That's probably enough, right? Undefined reference to SCM boot Guile. Why did that have a problem? Oh, that I messed up. Okay. Let's do that. So libs, I probably should make this include this as well. Does that work? That should work, right? Yeah, okay. So let's try to run it now. bin/flux studio. Boom, look at that. We have an SDL window that popped up. And I think I should still be able to do things here like display test. All right, so they're currently separate, which is good. And if I quit this, it tears down the whole process, which is great. Okay. So now, it would be nice to clean up things whenever it shuts down. I'm not gonna worry too much about that at the moment. Also, let's make this be a 16:9 resolution. So what was it, 1280 by 720? I know it's not a valid addition to package config. I made a mistake there. I seem to be about, I don't know, 20-30 seconds ahead of the chat, so sometimes we'll figure it out. Oh, come on. Let's not play code cleanup right now. Okay, so we are making progress here. We got SDL starting up, which is good. We're not rendering anything yet, but that's something that can be done. So now I just want to stop for a second and think about how I want to proceed with having a file that could describe some graphics. So let me pull up another folder called, let's say, examples maybe. And we'll create an example called basic GFX. I don't know, something like that. So the point of this is to start to figure out the starting point for how I would write the language for how to describe a graphic that's being created here. Dan says, is the SDL window created when you run your program? Yeah, it was in the center of the screen. I don't know if you could see that. It doesn't really show anything. It's just like a square box that showed up in the center of the screen. I wonder if that's going to show up in the OBS. That's going to be interesting to find out. Okay, so what we'll do is we'll start with something like a rectangle. We can just draw like a rectangle to the screen. So I'm trying to think of the right way to describe this, and also to initialize the subsystem for showing the window. Because what I would like to do is have it be possible to preview something while you're interactively writing it. So let's just say, I'm just going to sketch out something here that may not make a whole lot of sense at first. So define graphic with a name like stream BG. And we probably want some properties for that. And whenever you do this, it should set the environment up so that it can either preview the graphic that's being created so that you can continue to reload this code and have it update the screen. Or if you run it as a shell script, it would just spit out the PNG file at the end. So let's see. Let me think of how I would do this. And maybe it's better to not go with something that was going to rely on macros yet, because I'm still not an expert at scheme macros. So, because they are different than Common Lisp and Emacs Lisp macros. So if we just go with something more straightforward and maybe more procedural at first, maybe that's better. So define stream BG. What I can try to do. Yeah, so what I need is like a sort of a lower level API that macros could call into to sort of cause things to happen. And so some things we're going to need are going to be like a display context. And by that I mean, is it in the REPL or run as a shell script, i.e. should we show a window? So that's going to be important for how these things get displayed while we're sort of working on it interactively. So here we have something that could basically be an object, and the properties of that object, or at least the members of the list, I guess, if we're just going to use a really simple data structure approach for this, like just use scheme list for describing things. Yeah, we could do that. We could try to start with that. So just go with plain A lists maybe, or even P list. Does Guile have P lists, I wonder? Let's see. Guile P list. It must have a P list library of some sort. Guile config, P lists, Guile reference manual. I see P list there somewhere. I think my green screen is starting to flop away here. All right, so P list. Set source property is install the association list P list as the source property list for object. That's interesting. That's the only thing here that says P list. That's Guile 1.6. That's too old. Let's look in the REPL. I don't know. Nothing about P list. Come on, man. There's got to be. Okay, let's look for this Guile property lists. Source properties, symbol props. This seems to be about debugging annotations. P list. Property list. Okay. Whatever. We'll just go with A list for now. Okay, so you could imagine that you would have something like a width and a height. Let's say a width of 1,000 and a height of 1,000, maybe. I don't know if you really need that. Sorry, I gotta deal with this idiotic thing. Okay, she says, I'm not a dev, so following the stream has given me insight into the process and gives me motivation to hack on something myself. Yeah, you should. It's a lot of fun. Sometimes it takes a while to get anything useful on the screen, as you can see, but I think we're making progress. Okay, so to declaratively say what we want to render, in this case it being a square on the screen, So let's say goal, draw a red square. I don't know if the comment text is visible enough on the screen, but it's a starting point. So draw a red square. So now the width and height actually corresponds to the image itself and not the shapes that are involved. So that would actually probably be some kind of sub list, like, I don't know if you would call it instructions for what to render or what, but we could call it that for now, like instructions. So I'm gonna say instructions and have a sub list here. And each instruction could be something like, let's say rect of width and height. Let's make this an 800, or maybe let's say, yeah, 800 by 800 rectangle. What color do we want that to be? Yeah, it's almost, yeah, instructions is a good way to put that, because we also almost want to have it be like a drawing context where you can set a color, like a foreground color, a background color, and then do rendering of certain things. Then you can sort of clear the context. Maybe this is a terrible way to do it, but it seems like a reasonable way to start for now. So how about this? I'm gonna make another nested list here. Let's see, set FG color, and I'm gonna set that to, it's gonna be red, so do 255, 200. This is gonna be RGBA colors. So alpha is the last one. We want to do alpha blending as well. So we set the foreground color 255, 000, and we draw a rectangle 800 by 800, and that's basically it. So now what we've defined is there's a graphic that we're drawing. The actual dimensions of the image that we're producing is going to be 1000 by 1000. Actually, we want to do two things. We want to do let's say we do draw a red square on a white background. So we would need to do two things here. Let's start with this. Set foreground color 255, 255. Rect 1000, 1000. So that's going to draw a rectangle. Oh, we also need position coordinates. So 00. We'll start this at 200, 200. So XY width height, XY width height. So that should put us a centered rectangle inside. And that might be a good enough starting point. Now the question is, how can we take this and then interpret it in C code to do the drawing operations with SDL? Nice thing is that if this isn't animated, which animation is a whole other story. I don't know if this instruction approach is going to work with animations, but we'll see. Maybe it will. But it should be possible to take this and render it. And you don't have to render every single frame because it's just, static image basically. So you can just render it once and not have to sit there and loop forever. All right, so StreamBG, we're gonna do another thing here. We're going to use modules. Let's see. So I want to pull in Flux. I'm trying to think of what I want to call the module for this. Flux graphics, maybe. Let's say Flux graphics. And then I can say render graphic StreamBG. All right. So that would be enough to get that going. But I also need something as well to, let's see. Show preview window, let's say 1280 by 720. And this stuff, excuse me, like show preview window and render graphic, I think those things are going to be hidden behind a macro at some point. So I could make a macro basically that you could define a graphic that causes these things to happen automatically. In fact, you could even do something like, unless get env or something like that. You basically just see what type of environment you're running in currently. or even show preview window itself can decide whether it shows a window if it knows it's in shell mode or in REPL mode. So basically what I'm trying to say is we can show the preview window, we can define the instructions for drawing, and then we can render the graphic. Good question from Fikri. Does it mean that we will be fully transparent since the alpha value is 0? Yes, thank you for pointing that out. That's a very good point. So let me go back and put 255 on there for the alpha value. Thank you, Fikri, that was great. Okay, so this is a good starting point. So what I'll do now is go into Flux Studio, Source, Modules, Flux. We're gonna say graphics.scm for now. And this is the point where we're gonna want to call into that C function, I think. So what I'll do, I'm gonna define a function called show preview window. I also need to set the module correctly for this. So let me go grab some code from my dot files. Yeah, that's fine. I just want to do this really quickly. Drop this in. I'm gonna change this to Flux graphics. Get rid of that stuff. We don't really need any other modules yet. We just need to define a module. And now we're gonna, I need to do exports though. So let me go to the utils. Okay, so export is what we need. We need to have an export list. I'll go here and push this down further. And here I'm gonna say show preview window. So we're just making a Guile module. Show preview window. And we'll add other things to this in a moment. So show preview window right now. Let's see, I think I put it to have a width and a height. And what this should do is init SDL show the window. And then basically just wait for anything to be passed through to render. Nicholas says 100 for centering or no. Actually, I think you're right about that. I think you're right about that. So we need to put it 100 left and down so that there's another 100 on the other side. Thanks, Nicholas. That's right. You folks are so helpful. Making my life easier. All right, let's see. What file was that in? The basic graphics. Okay, so let's go fix this. So we're gonna make this 100 by 100. So we're trying to draw a red square centered on a white background. All right. So we have this function defined. We also need render graphic. So I'm gonna go back to graphics. I'm gonna define the render graphic function. Graphic, no, I would just call it graphic. Or maybe, we can say A list for now. I don't know if that's a word that's already used in Guile Scheme, but like as a symbol. Graphic, whatever. Okay, so in this one, we need to transmit. I'm gonna need a way to communicate between the Guile thread to the SDL thread, basically to say, here, take this object and render it. The thing is, I can't mutate that object, so we're gonna have trouble, but let's not worry about that problem for now. We're just gonna do this thing really dangerously. So we'll see how that goes. Gavin asks, how exactly do you plan on getting these graphics into OBS? You can write plugins to OBS for rendering whatever you want, like audio or video. So I don't think I'll do that. I think what I'll do at first is render them out to videos and then, put them in myself as stuff in the scene configuration. So the goal would be to make this code possible of creating a video file or at least a GIF or something that could be put into the scene. Okay, So transmit instructions to renderer thread. Render thread. Okay, so basically what that means is I'm gonna have to change how main.c works here. And this is a good point to go and look into how you expose a function up to Guile. Defining new foreign object types. Don't really need to do that yet. I might do it in the future. General libguile concepts, linking Guile with libraries. So a sample Guile extension. This may show you how to put a function. Yeah, this is one I remember from before. So we're defining a, hold on. Let me think about this for a second. libguile defines SEMC define G subroutine. So we're saying there's a scheme function called J0, and it gets called into J0 wrapper. So this is the kind of thing that we need actually. So here's what I'm gonna do. We're gonna dump all this into main.c for now. In another stream, we'll start breaking things out into individual files to make this a bit more clean. So maybe, let's drop this right here. Oh, come on. I wonder if this SEM is a void pointer anyway. Probably is, actually. It must be a void pointer. So what I'm wondering is, no, okay. So we have, I'm trying to make a function that can call into init graphics. So the whole idea is just call init graphics. And also to not block, because that's actually going to initialize the graphics thread. So here we go, init graphics thread. I can actually return the graphics handle, but let's not worry about that now. We'll clean it up all up later whenever we have time. All right, so here, I'll call this init graphics. And on the inner main, what I'll do, did I paste that here? No. Okay, so I need that function, the subroutine function from the info here. All right, so I'm gonna drop this right here. I'm gonna need a way to like store all of the foreign function bindings somewhere, I think, at some point. This is probably the arity, that one there. I might have to put it to 0, but I need to figure out what the signature of this function is first. So init graphics, let's just do that. I wonder if there's a way I can make this part of a particular module. So we'll say init graphics here. And I don't think I need to pass this. Init graphics, you know, that may actually be where I need to pass in the width and height. So how about I do that? SEM width, SEM height. And I'll put 2 there. I think that's right. Init graphics thread. And I believe there's an SEM. Let's see. Int width, int height. Oof. Then I'm gonna have to pass that through here as well, which is gonna be a lot of fun. I'll deal with that another time. Let's see. To do pass width and height through. Uh-oh. Is this it? Why does it keep doing that? I keep telling it to do repeats. Thank you for telling me. This thing keeps jumping off the beaten path, I think. That's terrible. My channel's not monetized right now, so long as I don't take the video down, it will be okay. Okay, let's see. Let's start this playlist over again. I wish it would just do what I asked it to do. That's shuffle. That's my mistake. Wrong button. All right, so we'll do that later. And here, here's what we'll do. We'll put that back out. I don't want to have to deal with this not compiling. So init graphics. I will go back to graphics.scm. Init graphics with height. So that's how we would end up calling into that. Let's look at the info really quickly and see if there's a way to put it in a module. Putting extensions into modules, great. Load extension. Ooh, do I have to load this as a library? That sucks. I really don't want to have to deal with multiple libraries, but it might have to deal with that. Gon says, isn't LSP mode showing you the signatures of the functions? The problem is that I believe it's using LLVM. I don't know if it's actually picking up the package config paths from the make file. I'm guessing it probably isn't, so I don't think it actually can resolve them. Because you see, I've got a lot of complaints here. Implicit declaration of function is saying that it's basically not, there's no real function there, so yeah, it's not really helpful right now, to be honest. LSP shutdown. Yeah, let's just take it out for now. Okay. So we have init SDL. We have init graphics thread. We have init graphics. We'll just leave it be in the global scope for now. We're gonna have to deal with that another time, but I'm not gonna worry about that today. I just want something to get set up correctly. So basic GFX, we have our show preview window function. That's in graphics. We have render graphics. So both of these things should do something at this point. I'm going to go back into main.c. I'm going to take out the call to init graphics because I want the scheme file to actually be the one that invokes that. And then Flux graphics, that's fine. All that looks good. That should be runnable at this point. So if I go back to this, let's actually try to build it. Okay, so quit is undeclared. Main.c line 15. Ah, somehow I deleted that character. That's a lot of fun. All right, so that built. Now, if I run bin/flux studio, it runs. Now, the important thing is going to be to run the REPL, so run geyser. All right, so now the REPL is up. And if I were to go into basic graphics.scm and I were to geyser eval buffer, this is Control-C, Control-B. Where are we? No code for module flux graphics. Okay, that makes sense because we have not added it to the load path yet. So the next step would be finding a way in the C libraries to add something to the load path. So let's go back up. API reference, let's see. Control mechanisms, read, load, eval, load paths, where Guile looks for code. So there's a load path variable, obviously. I could probably do that in my init file, actually. Maybe that's good enough. Let's try that. Init.scm, that's something you can do. Is there a function for that? Load path, load from path. Add to load path, great. So add to load path. In fact, I can try that again. So the REPL's still up, add to load path. Let's see, source/modules. Okay. And then what if I go back to basic graphics and then use this use modules, Control-X, Control-E. No code for module flux graphics. So did I miss something? Let's look at the load path variable, load path. Source/mod. Okay, so that didn't actually specify it fully. Let me figure out how to resolve a path. So Guile path functions. Okay, load paths, file system. How about that? Access, resolve, path, lstat, read link, change owner, utime, symlink. I mean, I guess can I get the current directory? Let's see, current, make dir, utime, send file. Come on, man. Let's see, D. Let's go back to POSIX. Ports and file descriptors. Current. Okay, let's just try it in the REPL. I think there's a current directory function. Come on. Current directory. An unbound variable. Current file name. No. How about that? Current. We have two pop-ups here that are fighting with each other. Get out of here. Okay, let's say Corfu. Get out of here. All right. Current dash thread file name source location working directory. Nope. Come on. Directory dir name. What is dir name? It's a procedure. Okay, that makes sense. So current file name. Nope. Okay. Okay, let's see. We're making progress at least. Let's just do this really quickly. Home, Davey Will, projects, code, Flux Studio, source modules. All right, so I put that in, and now I'm gonna go back to basic graphics. Syntax error. Okay, so define render. Okay, yeah, that makes sense. I didn't actually put anything inside the function. So we will say display. I would be rendering here. Now I can try to go back and load that again. I think it's gonna work if I do that. Okay, so it pulled that in. Show preview window. Unbound variable init graphics. Now, why is it not finding that function? We've built this again, right? Whoa, what just happened? Okay, so let's just bounce out of this whole thing. Probably it didn't restart the REPL. Let me just go back to vterm and rebuild it. See, this is why I was saying that we need to have a quick way to start everything up again. Okay, so Flux Studio is up to date. Control C, Control Z. Control C, Control Z. Did you do it? Okay, REPL. Okay, let's go back to basic graphics. Eval this. I lost what I had set. Init.scm. I'd set that though. Come on. Something's wrong here. I don't think it's loading the right thing. No code for module. This is very weird because it should have written this display string out whenever the REPL starts up. I don't think it loaded the right REPL. Let's kill that. Yes, kill it. Okay, so inside of this project, I'm going to run Geyser. There we go. Okay, this is the right one. Now we're going to go back to basic graphics. Eval that. Okay. So, warning, compilation failed to create path for auto-compiled file. I don't know what that means in this context, so I'm not going to worry about it. All right, so this one, unbound variable still init graphics. So I wonder why it's not actually showing up. Because I did recompile all this. Boot Guile. Let me check the example again, maybe. info. Ah, canonicalized path. Wow. Okay, thanks. Let's check that out. Cool. Is there a way to get help in here? Inner help. Inspect commands. Help. Inspect. Okay, that's cool. I need docs. Help all. Jelp. Statistics, inspect, disable, blah, blah, blah. This is debugging stuff. Trace, time, compile, language, help, show. Describe object. Okay, so describe, what's it called? Canonicalized path. Cool. Scheme procedure, return the canonical path of path. The canonical path has no dot or blah, blah components. Well, let's try that out, actually. Canonicalized path. What was that supposed to be? Source slash modules. Okay, great. That works. Thanks, Ashraz. That's great. Init.scm. Let's go back here. Canonicalized path. Push that over. Let's just do this the nice way. All right. So that should be enough. See, add our modules to the load path. Let's play the loading string. Okay, so now we can have our modules set up. This is probably not the best way to do this, but yeah, we're gonna do it for now. So the big problem we have is that the function we defined here, this init graphics function, is not being exposed up through to the Guile layer, and it doesn't know that init graphics exists. Can I go back to info? Okay, so let's go back up. Let's see. Foreign function interface. Foreign functions. And this is probably something different than what I'm actually looking for. Yeah. I want to define functions that get loaded up. All right. Procedures. Primitive procedures. Okay, here we go. Documentation. SCMC make G subroutine. What was I using here? Define G subroutine. All right. So the top of the docs here says define subroutine is likely to be the most useful mechanism combining the process of registration and definition. Register a C function and additionally create a top-level scheme binding for the procedure in the current environment using SCM define. Okay. The CC, CD, CD not give docs? It might. Let's actually see. Control C, Control D, Control D. Yes, it does. Thank you very much. I know there's all these little geyser things that I don't actually use, and I should use them. So that's good that that actually worked right now, because I need that. Do the same thing here. Control C, D, D. Boom. Add an element to Guile's load path. Great. Okay, so we're trying to figure out why my definition is not working. Let's go back to the info docs. Int REQ. What does REQ stand for? Okay, the arguments REQ specify the number of required, optional, and rest arguments respectively. Okay, so I did do that. Total number of these arguments should match the actual number of arguments of the function, but may not exceed 10. The number of rest arguments should be 0 or 1. Okay, so you can basically define a lambda procedure here. Name, and then the number of arguments. Rec, opt, rest, function. So we have 3 integers and then the pointer to the function. Init graphics. Init graphics takes 2 parameters, required parameters, and returns a scheme object. So that should have worked just fine. The question is, I mean, I'm guessing I have to define that inside of the thread. Function snarfing, a way to define new functions. What is, oh, okay. You're ripping them from a header file, I think is what it does. It's a program, all right. Let's see, linking programs with Guile. Does it show me anything? Sample Guile program, initialization functions. Okay, sample Guile extension. We're back here where we started. Init Bessel. That's not the whole example though. That's just for this module. That's really weird. Load extension. Load extension, Guile Bessel, init Bessel. So what is that supposed to do? JO wrapper, init. Oh, there's an init function for loading the extension. Ah, that's interesting. Hey, Alex. Okay. It's really interesting how this is just not working, because I think I'm doing it right. Let's try putting this after loading that file. I don't know if it matters, but we're going to see. I'll go back into the vterm, rebuild the program. Okay. Now, jump back into the REPL. Can I do Control-C, Control-Z? Will it restart it correctly? No. REPL, geyser, REPL, restart REPL. See, the thing is, I got a feeling that it's not starting the right REPL again. It's doing something wrong here. It's not actually starting my process that I told it to start. So I gotta like go back and run geyser one more time. And that's not even the right one either. So let's do this, run geyser. Oh. How do you... Ah, that's annoying. Okay, so I got a problem with the dir local variables. It's actually picking up the path to examples. Let's try it here, run geyser. All right, so that is the right thing, loading Flex Studio, okay. So now, let's just try init. Okay, init graphics shows up here. That's weird. Is it because it gets loaded into the Guile user namespace? Let's just give it some arbitrary parameters, init graphics. Haha, I crashed with no information about why. Interesting. That's very interesting. This is going to be part of the fun here. Ashra says you might need to write a Guile extension instead. Yeah, I don't know. I don't know why all of a sudden it showed up there and not elsewhere, unless it actually does get... I wonder if I could tell if I were to use describe on it. So let me just start this over one more time. I'm going to have to end the stream in a moment, but let me just try this one more time. So I'm going to kill this, and then I'm going to go back here. I'm going to run geyser one more time. Describe init graphics. Okay, it doesn't tell me anything. There's no docs. That makes sense. I just wondered if it would tell me what module it's in. But the thing said it puts it in a top level namespace, like a global namespace. So I don't know why it wouldn't be available to something else. So let's go back to basic graphics. All right, so I loaded Flux graphics. And let me try to run show preview window. Okay, so unbound variable init graphics. Something, I think. All right, so Guile module scope. I wonder if the module scope doesn't include the global. This is not dead, but the previous one before, it definitely seemed like the REPL died. Give me the latest manual. Oh boy. Huh. chat delay is almost a minute. That's not good. I might have to write a Guile extension. I really didn't want to have to do that because that sort of ties things together too much. Unless there's a way to get to the symbol in the global namespace, because clearly I can hit it in the REPL. I don't know why it's not accessing it correctly. So if I were to say init graphics here, it's there. The procedure is defined. It's callable, and if I call it, oh, wrong number of arguments. Okay, at least that worked. So 0, 0, boom, and it kills it to the point where it says it's been nice interacting with you. So it means that the process is dead. So it must have seg faulted. Was there anything in particular that I did that would have caused that, I wonder? Main.c, init graphics thread. Did I change anything? Not really. Who knows? We'll have to investigate that more next time. All right, so let me put that on the to-do list for the next stream. Let's see. Figure out why init graphics can't be accessed in Flux graphics module. Also, figure out why init graphics is crashing the process. And we come up with a good debugging strategy. Probably running via GDB is the right way to do that, but yeah, I could probably do that. Ha! Gon says it has to run through the YouTube sensors board first. Yeah, well, you know how that is. I don't know if it's a delay that, like, you don't see it on the screen in the video until it comes back through the Streamlabs UI, or if it's just, you know, in me responding to something in the chat. I saw Alex's YouTube icon show up pretty fast in my side, but I don't know if that's what everybody else is seeing. Gavin said that's a pain. I've never had great experiences with FFI interrupt. I've had pretty good experience with Gambit Scheme with that, but I've never done this exact thing before, like exposing a function up using the direct approach. It's always been through a different foreign function layer that can call directly into C functions. All right, let's see. Anything else? An org capture template for that might be helpful. Tie into the SE stream on Friday. Maybe we'll have to do some Emacs hacking again at some point. Speaking of the stream on Friday, I need to like get a plan together for that. It's Tuesday. Okay, I got time. All right, so we did accomplish a couple things. Start building the language for describing graphic scenes. I did that. We also set up SDL. Excuse me. Figure out how to use Geek Shell to create a reproducible dev environment. I think we did that because we actually have a manifest set up, so that worked. Push the initial code to GitHub. I need to fix a problem I'm having with my SSH certificates before I can do that, because I can't actually push right now from this laptop. But after the stream is over, I will actually push, excuse me, the code to GitHub and the notes from this, so you can follow along with what we've gotten done so far. Unfortunately, we didn't get anything rendering on the screen today, but I think next time, in the next 3-hour block that we have for this, we'll be able to get something rendering. It's mainly just a matter of figuring out why the init graphics function is not initializing, and then we'll have to figure out how to pass things along to the rendering thread, but that shouldn't be too bad. Ashra says it's now exactly 16 UTC. Oh, all right. Well, at any rate, that was pretty good, I'd say. As far as like getting something done today, we got a few things done. We at least got the code compiling and the Guile Scheme runtime pulled in. We at least got an SDL window displaying, but we're not getting it done through the scheme code right now, which is fine. So next time, I definitely think we can get something rendering and at least get the basics of this sort of approach to creating graphics in the scheme layer put together. And once we can start getting some basic stuff together, then we'll try to put together a more thorough set of instructions, I guess, for how to render so that we can make, you know, full like full thumbnails, like what I would do for System Crafters or for Flux Harmonic, so that I can start using the tool to generate things. And then we'll have to save the image out to a file. And I think that SDL has something for that already, so that shouldn't be very hard. But yeah, I'm pretty happy with the result, and I'm looking forward to next time. It was a lot of fun for me. I mean, it's a lot of, you know, hunting and pecking, as they call it, trying to figure things out. But, you know, I knew that was going to be part of this. And I'm also very thankful to all of you who are giving suggestions throughout the experiment here. Alex says, I'm currently working on a pure C project in SDL2, so this series is going to be great. Yeah. I don't know. I like working with SDL in C, or I like working with C in general. It is a little bit of a pain, but it's fun. The challenge is nice. What are we playing right now? Okay. All right, folks. Anyway, that's all for today's stream. The next stream is going to be on Thursday at the same time, 1 p.m. UTC. It'll be a 3-hour stream just like this one, and we'll pick up where we left off then. And then if you're watching System Crafters, we'll also have a stream there on Friday as well. So we'll have our full week this time. Okay, thanks a lot, folks, so much for being here today. I really appreciate it. It's a great first stream. Very happy with the number of people who attended. All of you are awesome. Thank you so much for being here. And until next time, keep it creative, and we'll see you.